using work and energy to solve a problem. Tipper's page 168 has a block sliding across a surface. There's friction. Basically, the block starts from rest, and we're pulling with a force of 80 newtons. Let's see, first of all, if the block will start moving. It's always good to check that. If there's a maximum static friction force, that's going to be 60 newtons, and we're pulling with a force of 80 newtons. So there's a maximum static friction force of 60 newtons to the left, but we're pulling with a force of 80 newtons to the right, so static friction cannot prevent the box from moving. It will move, and then we don't have to worry about static friction anymore. All we have to worry about is kinetic friction. So what we're going to do is figure out the initial kinetic energy and the work done by every force acting on this box, and then use our work kinetic energy theorem that says the net work done on our box is the change in kinetic energy. And we can find the final velocity of the box that way. We're going to use the bar chart like they show. It's a good idea to use it a few times to kind of get a visual of which energies are positive and which are negative and how they combine. But after you do it a few times, you start to get a feel for it. You'll just write out the headings like I've written here as an equation. The initial kinetic energy plus all the work done on the box by every force has to equal the final kinetic energy. So let's work our way through these. The initial kinetic energy is 0 because the box starts at rest. The work done by gravity on the box is 0 because the height does not change. Let me write it out for you. This is going to be the force of gravity. You have to be careful in physics. We have lots of W's. We have W, I was using W earlier as the weight of an object, the force of gravity acting on an object, W, the weight. And now W is work. So in order to try to avoid some confusion here, I'm using F sub g as the force of gravity. We multiply that by the distance, and we multiply that by the cosine of the angle between them. So our box is moving in this direction, and the force of gravity is down, and so there's a 90-degree angle between them, and that gives us 0 work done by gravity. Do we have any springs in this problem? No, we don't, so they do no work. Friction, the work done by friction. That's the force of friction multiplied by the distance multiplied by the cosine of the angle between them. So the box is moving to the right. The force of friction is to the left. So that leaves a 180-degree angle between them. That's why we get this negative sign. The work done by friction is negative. The friction force times the distance. In this case, the friction force is mu times the normal force. We get negative 200 joules. So I'll go ahead and put that in here. The applied force is 80 newtons. It's being applied through a distance of 5 meters, and the angle between them is 0 degrees. The applied force and the displacement are in the same direction. Okay, so we get positive 400 joules. And we add them all up. We started with 0 kinetic energy. We did 400 joules of positive work, increasing the energy by 400 joules. We did 200 joules of negative work, decreasing the energy by 200 joules. So we ended up with a plus 200 joules over where we started. And if you wanted to figure out the final speed, I come down here and I say K final has to equal 1/2 m V final squared, and I know that's 200 joules. So my V final is 400 over the mass, and the mass is 10 kilograms. V final squared is 400 over m, so the square root of 40 is my final velocity. Let's take a look at the next page. On page 169, we're lifting a box straight up. In this case, it starts with some initial speed, 10 meters per second in the upward direction. In this case, it starts 10 meters per second in the upward direction. So it has some initial speed. And we reach in and touch it. Our student touches it and pushes up with a force of 80 newtons. And I guess our student has really long arms because they keep pushing on it for a distance of 5 meters. The mass is 100 divided by 10, or 10 kilograms. Our initial speed, 10 meters per second. 500 joules. And kinetic energy is always positive. The work done by gravity. This time we do have work done by gravity. It's the force of gravity times the distance times the cosine of the angle between them. In this case, the block is moving up, but the force of gravity is down. So we're going to get a cosine of 180 degrees. Negative mgd, 500 joules. Do we have any springs in our system? No, we don't. So they don't do any work. We don't have any friction in our system. We do have an applied force. We're pushing with 80 newtons over a distance of 5 meters, and we have a cosine 0 degrees. So we're adding 400 joules of energy. In other words, the force of gravity would cause the box to slow down. So it's doing negative work on the box. Our applied force would cause the box to keep going, to speed up. So it's doing positive work. If we did not apply any force to this box, we just launched it up with an initial speed of 10 meters per second and let gravity work on it, it would go up 5 meters and come to rest. It would take all 500 joules of energy out of our box as it went up. It would come to rest after 5 meters, and then it would come back down, and the force of gravity would be doing positive work on it as it came down, increasing the speed of the box. But because we're pushing up on it, it's still going to have some energy, but not as much as it started with. It started with 500 joules of energy, and gravity took out 500 joules, and we're putting 400 back, so we end up one less. We end up with 400 joules. And the reason, you can look here, the weight of the box is 100 newtons. That's the force of gravity pulling down, and we're only pushing up with 80 newtons. So you can see that eventually it's going to run out of energy. We keep it moving further than if we weren't pushing at all, but eventually it's going to stop and come back down. So if we want to figure out what our speed is at the end of those 5 meters, we know our final kinetic energy is 400 joules, and we end up with the mass was 10. The square root of 80 meters per second.